Welcome back, ladies and gentlemen. Today is section 8.6, and there is no exit question today. This is a synthesis day, so we're going to try to put together everything that we've learned so far this chapter. So basically, I'm going to walk you through a couple ideas and a couple examples, and we'll be done. The first thing that we're going to do is we're going to review all the definitions. Basically, 8.6 is all about putting it all together, throwing a drawing at you that has some sort of quadrilateral and seeing if you can determine if you can name it as a specific type of quadrilateral or not. So the way this is done is you go strictly off the definitions or any if and only if theorems or corollaries that we've had to go with each shape. Now I've put the definitions here up on the screen so you can see what needs to be shown for each shape, but I haven't shown all the if and only if theorems. The reason I say if and only if theorems is because your job will be eventually to prove that it's a specific type of quadrilateral, and typically the normal theorems, the non-if and only if, say if it's a rhombus, then such and such. Well, if you have the such and such, you can't show that it's a rhombus automatically from that. But if you have an if and only if statement, it works both ways, and you're free to do it however you like. So just a couple of things that are tricky. When you get down to the bottom of the list, trapezoid and kite. Trapezoid, the definition says exactly one pair of parallel sides, so you have to prove that you have one and you don't have another. And then the kite has that exclusion idea that the opposite sides cannot be congruent, so you have to not only prove that two consecutive sides are congruent, but you also have to prove that opposite sides are not congruent. So a little bit more detail is needed. As we go into the example problems, which are next, it's going to be a real good idea for you to see if you can do them on your own without any assistance or comment from me. So as soon as you understand what the problem is asking, I would ask you that you pause the video, try it yourself, and see if your answer matches what I put up here. First example, is there enough information in that picture to call PQRS an isosceles trapezoid? If there is, tell us how. If there isn't, tell us why. Okay, there is enough information here. We have here, now there's not a lot of things marked. For a trapezoid, we need to show that there is one set of parallel sides, but not two. And there's no markings on the sides to indicate that they're parallel or not. But we do have a lot of angles. And not only that, but we have a four-sided figure, so you could figure out the missing angle. But more importantly, check this out. 74 plus 106 is 180. So that means that these consecutive interior angles are supplementary to each other. So by the consecutive interior angle converse theorem, PS is parallel to QR. And therefore, we have one set of parallel sides, so we have a trapezoid. And by the same reasoning, we can show that 74 and 74 are not supplementary, so therefore they are not parallel. And then secondly, we need to show that it is an isosceles trapezoid, and that's pretty easy because once we have that these two are the bases, then we have a congruent set of base angles. So by theorem 8.16, that is an isosceles trapezoid. Next, we have three problems for you. I'd like you to pause the video and give me the most specific name you can for each type of quadrilateral, and then explain your reasoning behind each decision. If you've done that correctly, you've got a trapezoid, a quadrilateral, and a kite. The reasoning being, trapezoid, we have one single pair of parallel sides marked, and the diagonals are not congruent, so we can't say anything special like rhombus or, well, rhombus diagonals wouldn't be congruent anyways, and they're not bisected either. So rhombus would be bisected, rectangle or square, they would be congruent, etc. This one, even though it's got a lot of markings, it's got that side is a known length, these diagonals are bisected, but these ones aren't. And then we have congruent opposing sides, but we don't know anything about this side over here. There's just not enough any information to put anything together. You can't show parallel lines. You can't show uh, bisected angles or anything special. So it's just not special enough, so we just have to call it a generic quadrilateral. And then over here, this one's probably the easiest one. We have two pairs of consecutive congruent sides, and we can show also that the opposing sides are not congruent, so therefore it's a kite. That's all I have for you. Obviously, we're going to spend a lot of time in class just ironing out the details. So here's the assignment and the details on what is expected in that assignment. I'll see you next time.